Yeah.
All right.
Take five,
Take
six.
one.
Today we will be learning Objective 105.
Okay. Difference of squares. There's really not much for you to fill out on this. I just need you to follow along. Difference of squares, factoring. We've been doing factoring like for the last, I guess, week and a half now. And we started out by factoring, like if you had 3x plus 9 and you would divide 3 off of each of it, and that was undistributing. And then we started taking trinomials, and we called factoring, we were unfoiling. So you had a trinomial, and we'd unfoil it. This one is going to be a difference of squares factoring. You're still going to put it into two binomials like we do when it's trinomials. All right, that's all the wordy part of it. Let's just talk about what this is. First, you need to know when you're looking at a little expression, that's a difference of squares. The word difference in math, the word difference, means subtracting. So if I say a difference of squares, I'm talking about subtracting two things. So you're going to see two things, and they're going to be subtracted. Now the word squares in math, we're not talking about the actual like squares in geometry. We're talking about in algebra, a square would be like, as far as a number, 9, 16, 25. What else would be squares?
36.
36, 4,
144,
144,
Isn't it 81?
1 what? 49,
I
yeah.
think 81 is.
81. These are squares. Why are those things squares though?
Because it's numbers that are times. You have somebody at the door.
It's numbers times itself to get that
Number times itself. So you got 2 times 2, so that's 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5,
25.
6 and 6 is 36. Those are what make square numbers. Now,
7 and 7.
square letters. Those are square numbers. You also need to know when you're looking at a square letter, and it's kind of easy at first. Square letters look like x squared, y squared, h squared. That's usually what they're going to look like. Occasionally, they might be disguised as an even number, like x4. You don't. That's not x squared, but it's really a square because it's x squared squared. So if you ever have an even number, it's kind of secretly a square.
It's a special square.
Yeah, you're not. Those are just more complicated examples. You're not going to see a lot of like x4s. We're going to look at one out of this whole notes. All right, let's look at the next page. Now, when you're asked to factor an expression that has only two terms, so if you have a problem and it says factor, and there's only two terms, you might be looking at a difference of squares, but you need to know if you're looking at a difference of squares or not. Now, I haven't told you how we're going to factor yet, but I need to know that we can tell what the difference of squares is. Out of the three of these problems, which two show differences?
A and C.
B and C is difference. So what's wrong with A?
It's asking for something.
It's a plus. It's an addition, and that is not a difference. Difference means I'm subtracting two things. So this one is definitely out. So it's not this one. On these other two, though, on these other two, they are differences. I am subtracting. But which one's a difference of squares?
C.
Between B and C. Which one's the difference?
B.
B, because I got x squared minus, what is 36? 6 squared. On this one, x squared minus 17. 17 is not a square. What's the closest thing to it that might be square?
16.
16 would be square. 17 is not. So this is a difference, but not a difference of squares. So know when you're looking at a difference of squares. And then here's how you're going to factor them. We're going to take this exact one, and I'm going to show you how to factor it. So there's like a little bit of a pattern. And some of this is kind of repetitive, so you might be able to skip some of these steps. But to factor the difference of squares, use this pattern. When you see x squared minus 36, and your brain registers, oh, that's a subtracting of two squares. X squared, that's a square. 36, that's a square. The pattern for factoring it is, think of it as x squared and 6 squared, and then you put it in your two binomials. So it's like unfoiling it, but we don't have three pieces. And if you put it into two binomials, it follows this pattern. X plus 6, x minus 6. So if you got x squared minus 6 squared, put it into two binomials as x plus 6, x minus 6. if you refoiled this, say that you refoiled this. Yeah.
Squared minus 6 plus 6
Minus 6x
plus 6x minus 36.
minus 36. And then the O and the I cross out, and that's where you just get x squared minus 36. And that's why it works. So if you have a difference of two squares, make it x plus 6, x minus 6, like this one. Now here's a couple other examples, and they're all worked out for you. X squared minus 4, that becomes x plus 2, x minus 2. If say that you had the number in front of the number first and the x second, like this one, 49 minus x squared, well that's 7 squared, so it goes 7 minus x, 7 plus x. And then the last one, the number of course goes first, 8 plus x or 8 minus x. One thing that doesn't matter though, and you need to be aware of, is the order. Like if you go plus or minus, the order doesn't matter. Like this one said 7 minus x, 7 plus x. This would have been fine too. So it doesn't matter what parenthesis comes first. If you do the minus one first or the plus one first. And just be aware of that if you're looking at different multiple choice answers.
So both of them are right?
They're both right, yeah. It doesn't matter which binomial you put first, the plus one or the minus one. It doesn't matter. It's the same thing. If you foiled it out, foil this one, you're going to get that. If you foil this one, you're going to get that. So I don't care which one you put first. All right, complicated examples. The first one's more complicated because instead of just x squared, I got 9x squared. So I got 9x squared minus 16. If you're going to ask yourself, is this a difference of squares? You need to go, okay, not only is x squared, that's definitely a square, but is 9 a square?
Yes.
It's 3 squared. You got 3 squared and x squared minus 4 squared. So what you do is you end up putting 3x minus 4 and 3x plus 4. So if that number attached to the squared letter is square, it still works. On the next one, you got a number attached to 2 different letters. So this one that's 7 squared x squared, and that's 16 squared, or no, 7 squared x squared and 4 squared w squared. So I just need 7x minus 4w, and then 7x plus 4w. Think of 49 as 7 squared x squared. And then 16 is 4 squared w squared. So there's your 7x minus 4w, 7x plus 4w. And like I said, the very last one would have an x4 in it. Just to kind of throw you off. If it's a difference of squares, you got to go, okay, is 9 a square?
Yes.
It's 3 times 3. Is x to the 4th a square?
Yes.
X to the 4th is x squared times x squared. So you got 3 squared, and then you got x squared squared minus 6 squared. So what goes in the parenthesis? It's not 3x. You're going to go 3x squared minus 6 and 3x squared plus 6. And if you refoiled out this bottom, you're going to see that it turns into 9x to the 4th minus 36. Now real quick, just to look at a couple, because this goes so quick. And to make sure that when you show back up tomorrow, after going home and sleeping and forgetting stuff, that we can pick this back up. Let's say I got 25 minus x squared.
Minus 40.
Let's go. All right, I got a handful of problems right here. The very first one, 25 minus x squared. What you need to do first is know if you're looking at a difference of squares, and then factor it. So when you're looking at this first one, is that a difference of squares?
Yes.
Okay, first off, how do you know? How do you know it's a difference?
Because it's subtracting.
Because it's subtracting. Now how do you know it's difference of squares?
Because 5 times 5 is 25.
Because 5 times 5 is 25, and then x squared is by definition squared. So then, let's go ahead and, if you factor it, what does it turn into?
5 minus x squared. or
5,
x
just 5 minus
squared.
x, and then
5 plus x
plus
squared.
x. Just plus
Gosh,
x.
I keep saying
And remember, it didn't matter if you wanted to do this one first or that one first. You couldn't go wrong. If you want to go 5 plus x, 5 minus x, that's fine. Okay, I got 17 minus x squared. Now, is it a difference?
that. Yes.
Is it a difference of squares?
No.
What's wrong with
The
it?
17 is
Seven-
not a square.
17 is not. All right, now, this one, is it a difference?
Yes.
Is it a difference of squares?
Yes. No?
Okay, is 40 a square?
Um,
Yeah, what's close to it? 36 would be a square, and then 49 would be a square, so it's not. So it's a difference, but not a difference of squares, so we can't factor it like we were. Now this big ugly one,
Yes.
it's a difference. Is everything squares?
Yes.
64,
8.
and then the x squared, and then the 7, and the p squared. Okay, so then let's try to put this into some parentheses. The first one, this will give you what? 8x. Yeah, 8x. And then this will give you 7p. And I don't care if you want to go plus or minus here. If you go plus here, then just do it again and go minus here. Just like that. And then the last one, yeah, is that last one a difference?
No.
So are they squares?
Yes.
Yeah, but they're not. You're not going to factor it if it's a sum of squares. We're just doing differences of squares.
Did you just make that up?
What? Sum of squares?
Some.
I don't. Maybe there might be a thing. I bet if I Google search sum of squares.
Well, just the way you
Something
said
pops up.
sum of squares.
It's sum of squares. I'm sure it's something, but we don't have any way of factoring it. Okay, that's it. Difference of squares. Very, very easy. Hopefully it sticks when we come back tomorrow.
Hey, whenever you post that on your YouTube thing, you have to get our intro on there.
Oh, yeah.
From